بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the first major of Math 111 term 222. Let us have a look to the major. Notice that the time is 1 hour, and let us try to solve the questions together. This is the first question. It's a graph, and we need to answer some parts about it. So first, what is the limit when x approaches 1 from the left of the function? This is the graph of the function. To find the limit when x approaches 1 from the left, you find 1 on the x-axis. So this is 1 on the x-axis, and we need to approach this number from the left. So if we are approaching the number on the x-axis from the left, where is the graph? So here, if you are here, where is the graph? The graph is up. If you are here, where is the graph? The graph is here. If you are here, where is the graph? The graph is here. So if you are going in this direction, the graph is going in this direction. Where when x reaches 1, the graph will reach what? Y will reach what? This number, which is 1. So limit f of x when x approaches 1 from the left is just 1. What is the limit of f of x when x approaches 6 from the right? Again, this is the number 6. X goes to this number, but from the right. So we are approaching 6 from the right. So you are here approaching 6 from the right on the x-axis, and you are looking to the graph. Where is the graph going? So while x goes to 6 from the right, y goes up to infinity. So this is the limit when x approaches 6 from the right. The x values at which f is not continuous. Where are the discontinuity? Okay, the graph has discontinuity. Where? Here, this is a circle. So the graph is not continuous. When x is, he says the x values. So when x is -3, there is a hole. Okay, -3, there is a hole here. Okay, where else? At 1. When x is 1, there is also a discontinuity here. The graph is not continuous. So at 1. The graph would be continuous if you can sketch the graph without lifting your hand. Okay, but here I can't continue graphing because there is a hole. Here I cannot continue graphing because there is a gap. At 2 also there is a hole. So at 2 it's not continuous. At 6 also there is discontinuity. I have to continue graphing, I have to lift my hand and graph this part alone. So there are four x values at which the function is not continuous. What is f of 1? Well, to find f of 1, this means that x is 1. So again, this is the x-axis. These are the values of x. This is 1. When x is 1, where is y? Okay, here there is a hole. So it's not f of 1. But here, this closed circle, y here is what? Is 1. So f of 1 is 1. List all the vertical asymptotes. The vertical asymptote, it's any line in which the graph becomes closer to it. So this line, for example, this line, okay, the graph is becoming closer to this line, okay, the vertical asymptotes. So what is the equation of this line? It's a vertical line. So the equation is x equals, and the value of x is -4. So this is the equation of this vertical asymptote. Do we have another vertical asymptote? What about this line? This line. The graph is approaching this line from the right and from the left. Okay, so x equals to 6 is another vertical asymptote. So we have 2 vertical asymptotes. What is the limit of f of x when x approaches -3? Well, he didn't say from the right or from the left. Anyway, x is -3. So let us go to -3. This is -3. Now, let me check from the right. The graph is going where? To this number here, to -1. Okay, from the left, x approaches -3 from the left. The graph goes where? Up to what? To -1. So whether you are coming from the right or from the left, the graph is coming to -1. Well, f of -1, f of -3 is not -1 because there is a hole here. F of -3 is 2, but the limit is -1. So the limit is -1. Find the domain of this function. Well, I have a root and I have a fraction. First thing, the denominator cannot be 0. So x cannot be 0. I have to exclude this value from the domain. Also, there is a square root. What do we know about square root? We know that x plus 7, which is inside the square root, has to be a positive number. It can't be a negative number. Okay? So x plus 7 has to be greater than or equal to 0. If you take 7 to the other side, it would be -7. So this is the interval. Okay, let me draw the number line, the real line. Where is -7? Assuming this is -7. Where is the 0? This is 0, for example, because it's greater than -7. X is greater than means to the right of -7. So from -7 to infinity, that's the interval. But 0 shouldn't be included. So there is an open circle here. 0 is not included in the domain. So you can write the domain from -7 closed, because x could be -7, no problem. If x is -7, this would be defined. This would be square root of 0, which is 0. To 0. 0 has to be excluded. So I put an open brackets, union from 0 to infinity. Or you can write from -7 to infinity minus the number 0. Evaluate this limit. Well, first we replace x by 4. So I'll have 12 over 0. Well, 12 over 0, any number over 0, will give you either a positive or negative infinity. So the answer is positive or negative infinity. Now I have to determine whether it's positive or negative infinity. Well, x approaches 4 from the right. Approaching 4 from the right, this is 4 and you are approaching from the right, you are greater, x has values greater than 4. For example, 4.1, 4.2. 4.1, if you replace x by 4.1 here, the numerator is positive and the denominator is positive. Positive over positive is positive. So the answer is positive infinity. If you replace x by 4.1 and find the sign of 3x over x minus 4 is negative, then the answer would be negative infinity. Determine whether this function is even, odd, or neither. Well, to do that, we find f of negative x. And f of negative x means we replace x, any x here, we replace it by negative x. So I have 3, there is an x inside the absolute value. So instead of x, I'll have negative x. And times square root of x to the power 4. Instead of x, I'll have negative x, and I will raise it to the power 4 plus 1. Now, let us simplify this. What do we know about absolute value of negative x? Well, it is equal to absolute value of x. This is an important property of absolute value. Absolute value of negative x is exactly equal to absolute value of x. Absolute value of -3 is equal to absolute value of 3, for example. So times square root of negative x to the power 4, when you raise negative x to the power 4, the negative will disappear because -1 to the power 4 is positive 1. So actually you will have x to the power 4 plus 1. Now if you look to this, it's exactly the function. It is f of x. And when f negative x equals f of x, the function is even. Okay? The function is even. If they are not equal, we find negative f of x. If negative f of x equals f of negative x, the function would be odd. If not, it would be neither. Given the piecewise function, is f of x continuous at x equals 5? Well, the function would be continuous at x equals 5, if limit f of x when x approaches 5 equals to f of 5. Okay? And here there are three conditions. F has to be defined at 5. Well, is f defined here at 5? Yes, it is defined because there is an equality. You can find f of 5 here. It would be e to the power 5 plus square root of 5 minus 5, that's 0. So f of 5 is e to the power 5. Okay, so f is defined at 5. Second thing, the limit has to exist, and it should be equal to e to the power 5. Well, this is a piecewise function, and 5 at 5, the definition changes. So to find the limit of the function when x approaches 5, I have to find the limit of f of x when x approaches 5 from the right and from the left, because the definition changes. Well, when x approaches 5 from the right, this means I'm dealing with numbers greater than 5. When x is greater than 5, the definition of the function is 9 minus 2x. So now to find the limit, I replace x by 5. 9 minus 2 times 5, 9 minus 10, that's negative 1. Okay, so the limit from the right is negative 1. What about the limit of the function when x approaches 5 from the left this time? Well, approaching 5 from the left means we deal with numbers less than 5. Less than 5, so I'll use this definition. The function has two definitions, definition to the right of 5 and definition to the left of 5. So to find the limit, I replace x by 5. I'll have e to the power 5 plus 0. Notice that the limit from the right is not equal to the limit from the left. Limit f of x from the right is not equal to the limit of f of x when x approaches 5 from the left. And this means that the limit of f of x when x approaches 5 does not exist. And if the limit does not exist, this means that f is not continuous at 5. Okay, is not continuous at 5. The limit has to exist, and it has to equal to e to the power 5. Here, for example, you can say that the function is continuous from the left, because limit f of x when x approaches 5 from the left is equal to f of 5. So if he asks, f is continuous from the left of 5, but it is not continuous from the right, and it's not continuous in general because the limit does not exist. In the following questions, evaluate the limit. Okay. How to find the limit? I replace h by 0. If I replace h by 0, square root of 4 is 2. 2 minus 2 is 0. 0 over 0. I have 0 over 0. When I have 0 over 0, I multiply by the conjugate, or I try to factor. Well, here I have square root in the numerator, so I'll just multiply by the conjugate. So what is the conjugate? It is, you have two terms, the conjugate of two terms, exactly the two terms, you write them again, but you change the sign in the middle. So the conjugate would be square root of 4 plus h plus 2. And now how to multiply these two fractions? Well, I still have the limit. Do not forget the limit. Now multiply the numerator with the numerator. When you multiply the numerator times the numerator, remember u minus v multiplied by u plus v is u squared minus v squared. So 4 plus square root of 4 plus h squared. So the square root will disappear. I'll have 4 plus h. And then minus sign and square v, square the second term, which is 2. When you square it, it is 4. And in the denominator, I have h multiplied by these two terms. And I keep them like this because there will be canceling soon. Okay, 4 minus 4 is cancelled. And I'll have h in the numerator. And I also have h in the denominator. And because I did not multiply h, okay, I can cancel h with h now. and I'll still have 1 here in the numerator. So now I can replace h by 0. I'll have 1 up, and if h is 0, square root of 4 is 2, 2 plus 2 is 4, so the limit is 1 over 4. If I replace t by 7, I'll have 49 minus 49, that's 0, and here 49 minus 35 minus 14, that's also 0, so I have 0 over 0. There is no root here, so I try factoring. Well, factoring t squared minus 49, I can do it using this formula because I have u squared minus v squared. 49 is 7 squared. So I have t squared minus 7 squared, so I can write it u minus v times u plus v. So t minus 7 times t plus 7. Here are 3 terms. I can factor them. T squared is t times t, and I can search for 2 numbers. Their product is negative 14, and their sum is negative 5. So negative 7 and positive 2. Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. Now I can cancel t minus 7 with t minus 7, and I can replace t by 7. 7 plus 7 is 14, and 7 plus 2 is 9. So the answer is 14 over 9. Here, x approaches infinity, the limit when x approaches infinity. Well, when x approaches infinity, we just take the highest power, the term with the highest power in the numerator, and the term with the highest power in the denominator. Okay. If you replace x by infinity, you will get infinity over infinity. And now you cancel x cubed with x cubed, and 4 over 2 is 2, and the limit of 2 when x goes to infinity is 2, so the answer is 2. If f of x is between these two polynomials, find the limit of f of x when x approaches 5. I don't have f of x. I don't know the definition of f of x, but it's a function between these two. But I know squeeze theorem. Squeeze theorem says if the limit of this polynomial is equal to the limit of this polynomial when x approaches 5, then the limit of f of x will be also equal to the same limit. So squeeze theorem says find the limit of 6x minus 2 when x approaches 5. I replace x by 5. 6 times 5, 30 minus 2, 28. That's good. Find also the limit of 5x plus 3, second, the other polynomial, when x approaches 5. 5 times 5, 25, plus 3, 28. Good. So the limit of this polynomial is equal to the limit of this polynomial is equal to 28. So by squeeze theorem, the limit of the polynomial in the middle, okay, when x approaches 5, has to equal the same limit, which is 28. Find the inverse function of this function. Well, the first step is to replace f of x by y. And then we can interchange x by y. And then solve this equation for y. To solve this equation for y, I have to get rid of this 3, because to get rid of e, I know that len ex is x, but it has to be ex, but there is a 3 here. So I have to divide by 3. And now I take the len of both sides. And len ey minus 1, len cancels e now, and I have y minus 1 equals len x over 3. I just wrote the right-hand side as the left-hand side. 1 equals 2, you can write it 2 equals 1, there's no problem. Now I take 1 to the other side. So 1 would be, y would be 1 plus len x over 3. And we solve the equation for y. So that's the inverse function. F inverse of x is 1 plus len x over 3. That's the answer. Use the intermediate value theorem to show that there is at least one root of this equation in the interval 1 and 2. Well, a root of the equation means when I replace x by a number between 1 and 2, the answer would be 0. So I'll have an x-intercept between this is 1, this is 2. The function has to pass by the x-axis. There is a root here. Well, there will be a root here if I find f of 1 and it is positive, I find it positive, and f of 2 negative, or f of 1 negative and f of 2 positive. If this is negative and this is positive, then the graph has to cross the x-axis. So to solve this question, let me call f of x equals x to the power 4 minus 2x cubed minus 3x squared plus 7. Okay, this polynomial to the left. The right-hand side has to be 0 here. So if he writes 7 in the right-hand side, take it to the left-hand side first. This is a function. This is a polynomial. F is continuous on all real numbers, especially on 1 and 2, it is continuous, okay? Because it's continuous, and the intermediate value theorem, the function has to be continuous. If the function is not continuous, then this could be positive, this could be negative, but there is no root in the middle. So the function has to be continuous. Now let me find f of 1. What is f of 1? 1 to the power 4 minus 2 times 1 to the power 3 minus 3 plus 7. So it is negative 4 plus 7 is 3. Well, 3 is greater than 0. That's good. Now let us check f of 2. And f of 2 has to be negative in this case. So the function will have a 0 between 1 and 2. Well, f of 2 would be 2 to the power 4, and that's 16, minus 2 times 2 to the power 3, which is 8. So minus 16, 2 times 8 is 16, minus 3 times 4, that's negative 12, plus 7. So 16 minus 16 is 0, negative 12 plus 7 is negative 5, and this is less than 0. So one of them is positive and the other one is negative. So I can say that by intermediate value theorem, there is a root of the equation between 1 and 2. And this would be the answer of this exam. I hope you enjoyed solving it with me.